Hey everyone, welcome back to another exciting episode where we unravel the mysteries of the world around us. Have you ever wondered why you can see your face in a mirror? It's something we take for granted every day, but the science behind it is truly fascinating. Or why a spoon in a glass of water looks bent. These everyday phenomena are all about the behavior of light. Well, buckle up, because today we're diving into the fascinating world of light reflection. Light is all around us, and understanding how it works can change the way we see the world. First up, let's talk basics. Light is a form of energy that travels in waves, and these waves move in straight lines called rays. Light travels in straight lines called rays. These rays are the building blocks of how we perceive the world around us. When these rays hit an object, they can do a few things. They can pass through, get absorbed, or get reflected. Each of these interactions gives us different visual experiences. Reflection, which we're zooming in on today, happens in two main types, specular and diffuse. These two types of reflection are responsible for the variety of ways we see light interacting with surfaces. Specular reflection is what happens with smooth surfaces like mirrors. This type of reflection is what gives us clear and sharp images. The light rays hit and bounce off in a predictable, uniform way, giving a clear image. This predictability is why mirrors are so useful in our daily lives. That's why you can see yourself so clearly when you look into a bathroom mirror. The smooth surface ensures that light reflects uniformly. Now, diffuse reflection is a bit different. It occurs on surfaces that are not smooth, causing light to scatter in many directions. It occurs on rough surfaces, where light rays hit and scatter in many directions. This scattering is what allows us to see objects that don't shine. This type of reflection is why we can see non-shiny objects at all. Without diffuse reflection, our world would look very different. Each scattered ray reaches our eyes from different angles, and voila, we see the object. This scattering effect is crucial for our ability to perceive the texture and color of objects. But here's a cool twist: the law of reflection. This fundamental principle governs how light behaves when it encounters a surface. This law states that the angle of incidence, that's the angle the incoming ray hits the surface, is equal to the angle of reflection, that's the angle it leaves. This equality is what makes reflection predictable and useful. This rule is true for both types of reflection, and it's fundamental in understanding how light behaves. Whether it's a smooth or rough surface, the law of reflection applies. Let's do a fun experiment. This will help you see the law of reflection in action. Grab a flashlight and shine it on a mirror at different angles. Observe how the light behaves. Notice how the light always bounces off at the same angle it hits the mirror. This is a perfect demonstration of the law of reflection. That's the law of reflection in action. It's a simple yet powerful way to see the principles of light in your own home. Understanding light reflection isn't just academic. It has practical applications too. This knowledge is used in various fields to solve real-world problems. Engineers use principles of reflection to design everything from car mirrors to solar panels and even architectural lighting. And photographers, they rely on these principles to capture stunning images. They use it to create the perfect shot. By manipulating light, they can highlight their subjects in the most flattering way. So, next time you see a shiny surface or a perfectly lit photo, remember, there's a whole science behind why things look the way they do, all thanks to the fascinating phenomenon of light reflection. This understanding enriches our appreciation of the visual world. Thanks for joining me on this visual journey, and don't forget to like, share, and subscribe for more intriguing insights. See you next time. Keep exploring and stay curious.